Hey, Micaiah, welcome back. Hopefully you're doing well. Hey, Zen, welcome back. Good morning. Hi, Ellen. Good morning. Hey, Yassine, welcome back. Hopefully you're doing well. Joey G, welcome back. Good morning. Hello, Nadina. Welcome back.
Are you ready to take this out?
Hey, Irvin. Welcome back. Good morning. Hello, Jordan. Welcome back. Good morning.
What's up?
Hey, not much. Just hanging out. Hey, Kai. Welcome back. Good morning. Hello, Jumila. Echo.
You got practice today, right?
Yeah.
Alright, let me do the health check thing right now.
Hey, Tintin. Welcome.
Start.
Good morning, Ryan. Welcome back. Best class of the day.
Fever, no. Please see the positive result. No. Have you been in close contact with anyone? No.
Hello, Joseph. Welcome back. Hello, Nadal. Welcome. Hello, Faith. Welcome back. Hey, Bellman. Good morning. Hey, Alex. Welcome back. Good morning. Hello, Kim. Welcome. Hey, Wendy. Good morning. Hi, Philip. Welcome back. Thanks for coming on time. Hi, Frank. Welcome. All right. Welcome back. Hopefully you guys are doing well, staying safe, being smart. This COVID thing, it's back again, so brace yourself. The cases are increasing daily in Oneida County, so be smart, wash your hands periodically, wear a mask out in public, and do all those protocols, social distance, all that stuff that will keep you and your family safe. So be smart about it. You go to Walmart, practice social distancing, wear the mask. Let's get rid of this virus, hopefully sooner rather than later. All right, please check the attendance to the left. Please make sure it's accurate, precise, and ready to roll. Please edit chat or unmute yourself if I mismarked you. So you can unmute yourself or throw in the chat if I made a mistake. All right. Here we go, ready to roll on this beautiful day. Hopefully you guys are taking advantage of the weather yesterday, today, and the next week it's going to be really nice, especially for this time of year. All right, let's check out what the heck's going on for today. So here we go. Welcome back to the best class of the day. Good morning. Quote of the week comes from Albert Einstein. Hi, Mike. Please try to get here sooner. Leonardo, try to get here sooner, please. And Emma for next time. I know things happen, but just try. Quote of the week comes from Albert Einstein. And it's, education is not learning the facts, but training the mind to think. So when you go throughout learning the process, you're in school, don't just memorize the facts. Go through and try to get something at a higher depth. Try to understand the concept. Like when you're learning about the atoms, you learn about electrons, protons, neutrons. Think about it. Think about the whole concept. And hopefully you understand it on a higher level as well. You'll always memorize it that way. If you're memorizing facts, then it goes right out. But if you train your mind to think, how does that happen? Why does that happen? Then you're really understanding something. The daily agenda for Thursday, November 5th, 2020 is a day one. We're continuing on with the atom. Start off with a bell ringer, a little classwork type of thing, a little lab work type of thing together, or a bell work. Do a quick little math review, and then we'll get to topic 5, the electron configuration, the notes, a YouTube video, examples, and I don't think we're gonna get to the exit pass today. This might be a sign for tomorrow, but a heads up, you do have a couple assignments that are gonna be due on Saturday. You will have the opportunity to finish that up, obviously, tomorrow, electron configuration. So today, next class, maybe one more class, we will wrap up this unit. And then after that, we'll get to the periodic table, just go through the bare basics of it. And then you will have the benchmark probably next Thursday, next Friday, maybe Monday or Tuesday as well. So the quarter is quickly approaching. Be aware that you will have a lot of tests, assessments coming up. So get on your toes, be ready to roll. All right, start off with this bell ringer here, which is neon. It's up in the top left column. Please click on that. Actually, hold up. Before I do that, I do want to refresh for a second. And I did add some more documents up here. So again, there's the attachments, but there's more documents that I attached here as well, such as this one. I couldn't let the year go without showing my diagram of the history of the atom. If we were in class live and you had pencil and paper in front of you, I'd go through I'd make the whole whiteboard, like the history of the atom, like the timeline for Earth back in when you did in earth science. So then we would actually draw this. We go through all this stuff. Started with the Greeks. They said Thomas, Dalton, the atomic theory, and then the atom was just empty space. J.J. Thomson's cathode ray tube, how his atom was a plum pudding model. And then Rutherford brought the gold foil experiment to the table and said that the nucleus is a solid, dense, positive core, but the atom is mostly empty space. And then maybe the next side of the page, I'd say, hey, here's the second half of developing the atom. 1913, Bohr came up with the rings. Electrons travel in orbits. And then the wave mechanical model, what the atom looks like today, S, P, D, and F. You drew some nice diagrams of that, better than that. It's a probability of finding electrons. So there's another resource you can use to help you with topic number 1. Additionally, I thought I did put it on here. I thought I put the textbook up here for this chapter. Maybe not. But I will put the textbook, so reading up here, if you need an extra resource for the unit. But this is a simulation. I might go through this later throughout the class, but this is a pretty cool way to visualize and think of the atom. All right, now let's just check out the bell ringer for neon. So we're going to do this one. Go to, boom, looks like this. Identify a substance, subatomic particles for neon. All right, so you need this. You also need a reference table. You can use your hard copy of the reference table that I sent home to you, or you could download one on a PDF. So there's a reference table. You need that page. Or if you just type in Google New York State, NYS, Regents Chemistry reference table, you can find a PDF that you want to use. That's fine too. So again, Regents Chemistry. And then we'll rotate this one clockwise, that page. If I have a Chromebook, if I put 2 fingers down on the keypad, it gives you the right click menu. And then rotate it clockwise. I need this portion as well. So what you're going to be doing, you're going to be finding Ne, which happens to be element number 10. It's neon. So that's the first. Oh, shoot. Oh, no. Well, I didn't see that. I didn't realize all those answers were there. But I hope yours is blank. So you're going to open that document up. You're going to find the atomic number, name, proton number, neutron number, mass number, electrons, electron configuration, and you're going to figure out the nuclear charge, atomic charge, and then you have to draw this thing as well. So I'll clear that out. But anyways, you can see neon, Ne, so you're analyzing all the properties of this one right here. Sorry, I cussed, guys. I got a little nervous there. But that is going to be the element you're going to be analyzing. I didn't mean to give you all the answers either. It's an accident. All right, so neon's what we're going to check out. Hey, Tristan. We're going to bell ringer for Ne. So that's the element we're checking out. It is right here, bell ringer Ne. Click on it, and you're going to be working on that. So on this one, I did give you a little bit more information on it. So instead of making your atom, you just pull them in and make your boring for it too. I'm going to put you in breakout rooms. Please share this. Somebody from the group, you should have the ability to share now. So someone from the group, please share it. Someone be a leader. Talk to your classmates. Hopefully you guys can figure this out together. So I'll give you like 8 minutes to work on this. I'll put you in breakout rooms. And it'll be like 3 or 4 of you guys together. So take about 7 minutes, work on this, and I'll be around to help you if need be. Questions? All right, please join the room. Please talk to each other. Unmute yourself, share it with somebody. I'll come around to help you if you need help. Hello, group number 1.
Hello.
Hey, how we doing, all right?
Hi. Mm-hmm.
What's our approach? Are we just doing it separately, then just like talking to it, or?
I just said it was neon. I don't know if people heard me.
Yeah. So if you want to share it, you're more than welcome to share it. Then everybody can see exactly what's going on. I don't care if you do or don't, but it's just another visual instead of the black screens there. Would you guys like to share it or no?
I can't.
Thanks, Zen.
No,
Oh,
I mean, I can't.
Oh, that's all right, Zen. Someone just try to share it.
Here.
Thanks, Micaiah. Oh, that looks nice. All right, Neon. So now maybe you want to pull up like another tab of like the reference table.
I had it.
Unless you have, perfect. Scrolling up a little bit more. And click on that table and just, yeah, are you using a Chromebook? Oh,
No,
what are you using?
I'm on my own, my Mac.
Oh, wow. I don't know the features for Mac, but if you right click your mouse, maybe, and it should
No.
give you the,
I can't, like, I click on it. It doesn't work. I tried to do it because I knew I could have rotated it, and I didn't have that, like, option.
no, I don't know, Max. That's a different one. But I guess you have neon right there. You could just look at it. Kind of funny.
Mhm.
It's totally fine. Proton number. Atomic number is 10.
Yeah, 10.
So you have 10 for atomic number. That's the same thing as the number of protons. If you guys want to help Makai out, appreciate it. You guys could, if you want to split your screen up, you can too. You like the Mac or no?
I can't do like half of the features, like where you can do like, I think you do like control space or control period or something, where you make
Yeah.
it higher or lower. I can't, so I have to do like arrow.
Oh,
Like,
all right.
it's
There is
so
a
weird.
way for the window or the Mac ones. I don't know. There's like an app on the bottom or something. If that's, I don't know the features on that one. But all right, if you guys need help, hopefully throw some ideas off each other. Any questions for me before I go to another group?
No,
Thank
I
you.
think I'm good.
No.
All right, help her out, please. Thank you, guys. We'll see you later. Good morning, group number 2. My quiet group.
Hi, Mr. Brown.
What's up, Michael? How we doing?
I'm doing good.
Good. I shared my screen with you guys so we could look at something besides the blacked out screens. Did we finish it yet? Did we start it?
We were planning to all finish it and then we will check it.
Okay. All right. I'll leave you guys alone. You gotta something that works. All right. I'll see you later. Do you have any
All right.
questions before I get out of here? Anybody?
No.
All right. We'll see you later. All right. Thank you. Hey, group. Oh, wait. Why did I mute everybody? Anybody in this group? Don't know where I am right now. Hello, group. Oh, sorry to interrupt, John.
You're good.
So rude of me. Just coming into your party and start talking.
We're good.
Do we have any questions?
I'm doing good right now.
No,
Sorry.
we're settling.
What's our approach? Are we just going through it together and talking about it? Or are we
Yeah.
Yeah.
separately? All
Left
right.
side, now we have instruction.
We're all
All right.
learning from each other.
All right, cool. All right, you can share if you want to. All right, I'll see you guys later. Hello, group number 4, breakout room number 4. How's everybody doing? What's our approach? Doing them separately, independently? Okay, thanks, Joe. All right, so if you want to do them independently, that's fine. If you want to throw some ideas, that's fine too, off each other. All right, so here's my screen. I'll share since no one wants to be too vocal. I'll help this group out a little bit. So it's weird. Sometimes like the blend of the different groups, some groups are like fully on, talking, sharing, but no big deal. I don't care. Going through this process, we have this information. We have neon. If somebody wants to share it after I leave, you're more than welcome to, but I'm gonna just get you guys rolling a little bit. So we have neon over here to the left. Let me open up with a different feature so I can analyze it. Figures. So maybe you're already done with this. Maybe you're stuck. This is where I expect you to work with like a partner to kind of go through this process. But there's neon. Redo that. There's neon. Analyzing this, the name is going to be neon. The atomic number is going to be that big bold number on the bottom left, which is 10. What's the proton number? Anybody could chat it or you could talk. I don't care. It's a small group, so you don't feel embarrassed. Yeah, 10. Thank you. Number of neutrons. We'll skip that one for now. Let's do electrons. That up there, 2 plus 8 gives you total number of electrons. Electrons come from there, which is the same thing as protons, 10s. Electron configurations 2-8. The mass comes from right on top. So that one's going to be 20 point, if I could read still, 20.180. The units are AMU. And the nuclear charge comes from the charge of the nucleus. So what's going to be the nuclear charge? It's what's in the nucleus, the charge of the entire nucleus. Here's my nucleus. I already put my stuff in the nucleus. I have protons and neutrons in there. I guess I should fill out my neutrons now. Neutrons come from the mass as a whole, subtracted by the proton number. So take your 20, that rounds to 20, minus 10, gives you 10. So I have 10 protons and 10 neutrons. What's my nuclear charge? What's the charge of that nucleus right there? The atom's charge is 0. So in this situation, we have 10 positives. And then I have a bunch of zeros. 0, 0, 0, 0, 0, 0, 0. Those are all zeros. Overall charge of the nucleus is going to be just that positive 10. So the charge of the nuclear charge, the charge of the nucleus is going to be positive 10. That clicking noise, I know it's kind of annoying. I just rewatched another video. I'm like, oh, that's very obnoxious, the clicking. Hopefully you don't hear it that loud. The atom's charge, though, is going to be like when you have the protons, neutrons, electrons around it. It's a charge of everything. So now before I even do that one, I would just make my atom. First ring. First ring has 2 electrons. 1. So this is a Bohr ring. 2 electrons in the first ring. The second ring's going to have 8 electrons. So take that ring, put it around, ring around the rosy, pop, and 8 around the second one. So that would be your protons plus your electrons. What's the overall charge? Joseph told me it should be 0. So positive 10 plus negative 10 equals 0. All right, any questions? Not positive. So the atoms, the atomic charge, if I take my 10 electrons, 10 protons. So protons, we have 10 of them. And protons are positive. So I have positive 10 plus your electrons, which are going to be negative. I have negative 10. Plus your neutrons, I guess you could do that, which equals 0. So I have positive 10 plus negative 10 plus 0. That all equals, those two cancel out. What's left? A big 0. Nuclear charge is plus 10. The charge of the nucleus is plus 10. Why? Because you have positive 10 plus 0. That's where that works out. Know what, Joseph? We need help with, or might I mess up? Maybe I messed something up. Okay, gotcha. All right, guys, I'm gonna go to a different group, and I'm probably gonna get rid of the breakout groups soon. All right, I'll wait till everybody jumps back in from the breakout rooms, and we'll go through this question. I'll do it relatively quickly. So hopefully I had a chance to actually interact with some classmates of yours. I know it's kind of lonely sometimes being at home and really not interacting with anybody. So I would definitely encourage you to take advantage of the opportunity when I do give the breakout rooms to interact with people, go through it, talk to them, say, hey, what's going on? How you been over there? What's your whatever? Talk about some hobby. I don't care. The breakout rooms really want you to interact a little bit with each other. So anyways, going through this example, a lot of screens open up now. We have determined the following for Ne. We know it's going to be neon. So neon is a name. The atomic number comes from, I went through this with a group, so I marked up a little bit. So the atomic number is a big bold number in the bottom left-hand corner. So it's going to be 10. It's also the same number as protons. And it's an atom, so it's also the same thing as electrons. And it's also the same thing as the nuclear charge, which is 10. Those are like all teals in my notes. So when I analyze subatomic particles, protons, electrons, atomic number, nuclear charge, they're all the same. The electron configuration comes from the bottom portion. We'll see this today in class too. There's my, 2-8 is electron configuration. Hopefully you can see that. The mass comes from that green number. Which is going to be 20.180 AMUs, atomic mass units. The neutrons comes from the mass minus the proton number. Take your mass as a whole, which is going to be 20, subtracted by the proton number or the atomic number is 10. And then the atomic charge, the charge of an atom is going to be equal to 0. So hopefully you got all of those answers. Last thing you gotta do is figure out how to draw a Bohr ring for neon, not, oh, I think yours says O. We did oxygen last time, but neon for today, so make that change if you can. Here's a nucleus. You should know by now the nucleus has protons and neutrons inside. If you double click on the protons and neutrons, I just put 10 protons and 10 neutrons. What I've done in the past, I just put the positive charges up there. 10 of them, and then the neutrons, you can put the zeros if you wanted to. Why do I do that? Is so I can figure out the charge of the nucleus. If I have 10 positives and 10 zeros, what's left? 10 positive, 10 zeros gives you a charge of plus 10. The nuclear charge is a charge of the nucleus. The charge of the nucleus, nuclear charge, charge of the nucleus. The atom's charge comes from protons, neutrons, and electrons, so all three of these. So essentially you have positive 10 plus 10 zeros, which would equal the charge of 0, plus negative 10 electrons. So if you equate all that, figure plus 10, plus minus 10, plus 0, they'd all cancel out. The charge of the entire atom would be 0. Just fix these up here again. So making your atom, take the first ring. The first ring has 2 electrons around it. There's my little smiley faces, my electrons. Put one there, put another one there. The second ring would have 8 electrons around it. So we made a couple already. That 8 comes from right there. So take 8 electrons, put them around here. This is an atom. It will be an atom of neon. For in school, we'd actually go through and make an atom, a model actually of neon or something in your group, but this is the best we could do for making an atom at this point. So 2-8, so 1, 2, 3, 4, 5, 6, 7, 8. Does anybody have any questions on how we constructed that model? All right, so that's it. You could take this and save it for your reference. Another example to analyze, but again, we'll do one more example like that next time. And I'll probably grade that one for next class. So there's a bell ringer, done. Another thing before I go to the next thing, if simulation that I add to the classroom page looks like this. So I added this last night.
Hey, Mr. Brown.
Hey,
Mr. Brown.
Yes.
My parents just brought me breakfast. Isn't that cool?
That is nice. What'd you get?
Yeah. Oh, I got an omelet with like toast.
Where from? Oh, from home?
I don't even know.
It's got bacon.
It has bacon,
Cheddar cheese.
ham, and cheese.
All right, we'll be over. All right, you got room for
Yes,
28 of us?
sir.
We'll be over with mask. All right, so let's go get some breakfast. All right, so anyways, if we check out Build an Atom, this is on the stream. If I click on this little link right here, you can play with this stuff if you want to. I'm gonna click on the atom, and then you can figure out like more features for making atoms. So if I take one proton and I add it to the nucleus, you can see it's gonna be hydrogen, H. I'll throw these up here too. It has a massive 1. The nuclear charge is gonna be +1. Why? Because there's 1 proton. If I take another proton, add it in there, now it's gonna be helium with a nuclear charge, or net charge of +2. Let's see what happens if I throw an electron in there. Throw 1 electron in there.
Mr. Brown, I also got breakfast.
Oh, nice, Santino. Okay, we can split the group. Half us go to Santino's house and half go to Tristan's. We'll just cut in half, I don't care. So if I had 2 electrons there, now it's gonna be 0. So I have 1 positive, 1 negative, they cancel out. If I have 10 protons, I'm gonna make neon now. So you can see what happens when I add a proton. You can see how it's shifting over on this table. So I'm at oxygen, fluorine, now I'm gonna be at neon with 10 protons, so we can analyze that. We know neon has 10 neutrons in this situation. They could change. Why? Because the mass changes when the isotopes. So that would be 10, yes. So I have 10 protons, 10 neutrons. You can see that in the table above. And we want 10 electrons. So right now I have a net charge of +8 because I have 10 positives and 2 electrons. Neon needs 10 electrons. There's 3, 4, 5, 6, get in there, 6, 7, 8, 9. So I have 9 electrons right now. You can see this table. Cancels, 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 cancels. What's left over is just this +1. So that's not, it's an ion. So that's an ion still. If I take 1 more electron, add it to it, now it's going to be even. So that's going to be an atom. The mass number is 20. The charge is going to be 0 because I have the same number of protons and electrons. If I take an electron away, it becomes a positive ion. It's more positive in that situation. But there's a little simulation you can play with if you want to. You could take away protons. You could add another electron to it and see what happens. So this becomes an atom. Why? Because the protons and electrons are equal. If I take another electron and add it towards it, electrons are negative. If I take 1 more electron, add it on, it becomes a negative ion. So I thought that was cool. You can play with that if you want to. All right, I'm gonna skip the mass review for now. I'm not gonna go through the random questions. Sure. All right, topic number 5, electron configuration. We'll get to this topic and I'm gonna play a video, YouTube video on this. Enjoy your breakfast as you watch this video.
Mr. Brown,
Yes.
do you want us to hand in the bell ringer?
That does not have to be submitted. The next one will be submitted so I could grade that one for like an
All right.
yes. Thank you. Good question.
You'll need to be familiar with the structure of an atom before going any further, and you may wish to look at the lesson Parts of an Atom, Their Charge and Their Mass first. Electrons are arranged in energy levels or shells around the nucleus of an atom. The actual orbit shapes are a bit too complicated to cover in such a short lesson, but on average, the orbital radius increases as the energy levels increase. In our diagrams, the shell nearest the nucleus is going to represent the lowest energy level or shell, and we draw a circle to depict each shell. We use a dot or a cross to represent each electron, and we'll represent the nucleus by the chemical symbol. Each electron in an atom is in a particular shell, and the electrons must occupy the lowest available shell nearest the nucleus. So, when we are drawing the electron configuration, we have to fill up each shell in turn, starting with the lowest. We'll take a lithium atom as an example. With an atomic number of 3, it must have 3 electrons to balance the positive charge of the 3 protons in the nucleus. It's worth remembering that the atomic number tells you the total number of electrons in a neutral atom. So, we put the first electron into the first shell, and the second. However, this shell can only contain a maximum of 2 electrons. That's one of the rules that you need to remember. The third electron, therefore, must go into the next shell, which we draw as a larger circle around the outside of the first. And that completes the electronic configuration of a lithium atom. The same process of filling up shells applies to larger atoms. You always start with the lowest available shell, and whenever a shell is full, the next electron to be added goes into the next shell. And that's pretty much it. All you need to know is how many electrons can occupy each shell, and at this level, you only need to know the rules for the first 20 elements. The maximum numbers are as follows. The first shell can contain a maximum of 2 electrons. The second shell, up to 8 electrons. The third shell also has a maximum of 8 electrons. And the 19th and 20th electrons go into the fourth shell. And this would actually represent a calcium atom. Note that as we fill up each level, we've been drawing the electrons evenly spaced out on each shell. This is to keep the diagrams tidy and make it easier to count the electrons. And what's more, there's a shorthand way of writing this down. 2, 8, 8, 2. The first number represents the inner shell or lowest energy level. The full stop shows how the electrons are separated between the shells. The second number tells us how many electrons are in the next shell, followed by the third and fourth shells. And so now it's your turn. I'd like you to draw the electron configuration of a carbon atom. Pause the video, find a piece of paper, and have a go.
We're not going to do this. We'll practice more throughout class.
And here is what it should look like. It has a full first shell and 4 electrons in the outer shell. Did you get it right? Now, how would you write the electron configuration in numbers for this atom? Pause the video again, or rewind if you need to have a think about this. The answer is that it would be written 2.4. And now that you have covered the basics of drawing electron configurations, you'll be ready to tackle our lesson, Electron Configurations of the First 20 Elements.
Okay, so electron configuration, nothing too crazy there. Stuff we already talked about. You already know how to make a lot of these already. So here we go. Please open up your guided notes. Please open up to topic number 5. So a quick little review. I was going to have a review with you guys and just ask random questions like I did the previous class. I'm going to skip that for now to save time and get a little further on electron configuration. All right, so we went through the history of the atom. Done. We went through subatomic particles, protons, neutrons, electrons. Done. Ions, an atom with a charge. An isotope is going to be same element, different mass. Same element, different number of neutrons. And then yesterday in class, we went through calculating atomic mass. So that's where we are. We're going to go through and go analyze electron configuration today. I'm going to highlight that. Topic 5, our goal for today. We talked about Dalton's atomic theory. We talked about J.J. Thomson, the cathode ray tube experiment. Rutherford's gold foil experiment. We know what it proved there. Bohr's boring. We'll see him again today. The wave mechanical model, the probability of finding electrons. You drew these SPDIF models. Look cool. Topic 2, you talk about protons, neutrons, electrons. You know, protons positive, neutrons neutral, electrons going to be negative. Proton and neutron have the same mass of 1 AMU. You should know that one. We should know protons, neutrons are located in the nucleus. Electrons are so small they orbit around the nucleus. Hopefully you know how to determine protons, neutrons, electrons. We'll practice that one more day with a bell ringer. We made an atom of carbon. You should know the difference between an atom and an ion. Atom is neutral. Why? Because the proton number and electron number cancels out. And anion is negative. Anion, negative, because it gains one or more electrons. That negative means it gains an electron. Cation has that T, it's positive. Cat, positive. Why is something positive? Because it loses an electron. It loses a negatively charged electron. And we left off with isotope. Same element, different mass number. Isotope, same atomic number, but a different mass number. And we analyzed 2 examples of that. And mass, we did this yesterday in class. We calculated atomic mass of boron. Additionally, calculated atomic mass of H. That's where we left off. Moving on forward, here we go. Electron configuration. So this topic should be a lot of review from what I already introduced. Electron configuration is a dash chain of numbers found in the lower left corner. So lower left corner of an elemental box, see below. It tells us the number of energy levels, as well as the number of electrons in each ring, in each level. So electron configuration, you know where it is. We already made some borings for it. You already analyzed it. Bottom left-hand corner, that's electron configuration. So once you write those few words in there, I'm going to double click on that little box right there. So if I double click on it, it brings us to obviously the drawing page. And inside that red text box, I'm just going to put electron configuration. So double click in that text box below and you can put electron configuration. So that tells you how many electrons are on each ring. You make a boring model, it tells you how many electrons are on each ring. Electron configuration, save it and close it. Easy.
Where is that?
You have this picture or no?
It's like I can only see a 12.0, like the top of it, because it's like completely cut off.
Oh, okay. So it's I'm guessing it's like in between pages.
Yeah.
So after click off of your atomic mass and just go down once or twice. Once you're
Okay.
outside of that little text box above, just press enter a few times until you see it all. Hopefully it pops up there.
Okay, yeah.
Okay.
Thank you.
You got a text message too. You're welcome. Or maybe a snap.
Yeah, it was Snapchat.
Oh, snap. No, it's a snap. I'm not into snap. I'm into just Google Pics. My kids. I'm an old man. That's okay. All right. So anyways, all electrons on the periodic table are going to be atoms. So does anybody else not have this image there? It's going to be atoms. An atom is going to have the same number of protons as electrons. They're both going to be equal. Atoms, they're equal because the protons equal the electrons. In the situation for ions, so you have to definitely differentiate between an atom and an ion. An ion, you add or subtract the electrons from the last number. The last number and the electron configuration. And we'll go through several examples today. Tristan, I'm sure I'm already on Snap somewhere. I'm sure someone's got a picture of me doing something silly. I'm sure it's like already out there, so maybe I'll go big time there. Maybe I'll go viral for being an amazing chemistry teacher or something. Maybe not. All right, so anyways, there's the example. So ions are going to be adding or subtracting from the last number in the electron configuration. So let's check it out. So I have some examples, and I'm going to need a reference table to analyze these ones. these examples. I have magnesium, I have the substance, and I have the electron configuration. So first substance is magnesium. Let's check it out. And they have electron configuration already given to you. So in my reference table, make the screen a little smaller. So hopefully you're getting a little bit better with manipulating your screens, making things smaller so you can see everything here.
For this sentence where it said like for blank add or subtract electrons, that's ions. Okay, yeah. Yeah.
Yep. All right, so let's check out the periodic table. First one is magnesium. So if you have a hard copy in front of you, I'd encourage you to use that because this can get a little crazy when I see these at a larger scale or zoom in or zoom out. So find magnesium. If you don't know what magnesium is, you go to the next page and say, oh, magnesium is going to be Mg because it's element number 12. So that's magnesium. There's magnesium right there. I'm going to zoom in on it. Magnesium. Mg. So that's the element we're analyzing. So I don't care about anything else on this periodic table but this element right here. So when you really break up each and every element one by one, it's not that difficult. You know this is a mass. You know this is a proton number, atomic number, nuclear charge. You know that's the electron configuration. And this, we're going to start to get in more and more. That's the ions, or how many electrons it can gain or potentially lose when it bonds. So here we go. The electron configuration comes from the bottom left-hand corner, which is right there. It's 282. This tells us there's going to be 1, 2, 3 rings. Another thing to note is what period it's in. So periods go from side to side. It's like reading a book. If you scroll on up a little bit, it says periods. This would be period 1. So I'll make another connection now. So there's 7 periods. Hopefully you can see that. So period 1, there's 1. Here's period 2, period 3. Don't fill this out like this. You don't have to. Period 4, period 5. So there's 7. You can see this. 6. And additionally, this would be a part of period 6. Period 7 will be this last one on the bottom. So period 7, this is all period 7, along with this as well, which would be smushed up there too. But they don't do that just for the sake of space. They don't really have a ton of space on a piece of paper. If they snuck all those up there in that one little section, then those little elements would be really, really small, and you wouldn't be able to see them really well. But let's just analyze, I guess, magnesium. So period 3. So the right here, the yellow line we're going to check out. Check out to the left first. So period 3, I have magnesium has 3 rings, 3 shells. If I look at Na, it has 1, 2, 3 shells as well. So that has 3 shells here too. So 3 rings. Now let's go over to the right and analyze more elements there. All right, this has 3 rings, 3 rings, 3 rings, 3, 3, 3. Every element in period 3 has 3 rings, so 3 shells. Let's check out period number 4. Period 4 has 4 rings, 4, 4, 4. So every element in period 4 is going to have 4 rings. Let's go to the right. So this has 4 rings, 4 rings, 4 rings. Same thing for KR. So every element in period 4 has 4 rings. Same thing for period 5. So every element in period 5 is going to have 5 rings. You can see that connection. There's 5 rings there. 6 will have 6 rings. 7 will have 7 rings. Can't have more than 7 rings though. So that's going to 6, and we'll talk about this one in a second though. It's going to have 7. So the period number tells you how many rings. Thank you. The period number tells you how many rings you have. So period 2 has 2 rings. That is correct. So the period number tells you how many rings you're going to have. Good to know. All right. More information. Next one, I have magnesium +2. So magnesium is now going to be an ion. It's a +2 charge. So that +2 means it's a cation. And I'm not adding 2 electrons. I do the opposite of what it says. So magnesium +2. So this would be magnesium 0, which would be 282. But magnesium +2 means I'm not adding 2 electrons, but I'm taking 2 away. So again, +2 means there's ions. Plus means it's a positive. It loses electrons. A negative, why is it negative? Because it gains a negative charge. It gains. So positive, we have to lose 2 electrons. Where the heck are we losing them from? That last ring. So Mg +2 means it will lose 2 electrons. Okay. Bromine happens to be Br. Let's just check out that one. Next element is Br. I'm going to open up a new reference table. Too much going on there for me. And I haven't figured out how to use Cami to delete everything all at once, so I'm just going to make a new copy. I don't think you have this extension on your Chromebook from school. We are working on it. The tech department is working on it. It's not a bad feature, I don't think, at least for me to teach it. If you have your own reference table, that's fine. You can just analyze it, go through it as we do it together. But find Br. Br is going to be to the right. There are 2 liquids on the periodic table of elements. One of them is going to be mercury, which happens to be right here. Mercury is element number 80. That's a liquid. The other one's going to be bromine, my element. Mercury is the stuff they used to put in thermometers back in the day. I'm a liquid. My name's Brown. I'm a liquid. Whatever. You should definitely know 2 liquids on the periodic table. I think the benchmark has a question like that. Which one of these elements is a liquid? Mercury or bromine? Or they'll give you a bunch of elements. If mercury is an answer or bromine is an answer, that's the correct one. Your benchmark is going to be 40 questions. It's going to be everything from unit 1 to basically where we are before the benchmark. All right, so we're analyzing bromine. There's one question you could get right for sure. So bromine atom, it's not doesn't have a charge over here, so it's going to be an atom. The configuration is going to be 2-8-18-7. So if I gave you just that right there, the electron configuration, you could say, oh, it has 4 rings. It must be in period 4. So check it out. It is going to be in period 4. The number of rings tells you what period it's going to be in. That atom has 4 rings. It's in period 4. Now if we analyze Br with that minus sign up there, so that -1, this minus oxidation number that's referring to. So Br -1, that's an anion. So what's going on there? It's going to have to take in 1 more electron. So why is it negative? It's because it's going to take 1 electron, take a negative electron, pull it, put it on top of you. It's now going to be more negative. So if I take 1 more electron in, it's going to make the configuration to 2-8-18 and 8. Make a stable octet, it's called. So 2-8-18-8. There'd be 4 rings there. Questions on that one? So you should be aware of what these charges represent. -1 means you add an electron. +2 means you lose 2 electrons. So here's my joke of the day. What do they do with dead chemists? So what do they do with dead chemists? They bury them. They bury them. It's an element. So dead chemists, they bury them. Good joke today. Barium is element number 56. Joe, would you have a question? Let's see. So if it's +1, Yes, Joe, that would be correct. So we'll analyze more of them too, though. Thanks, Mike. All right, so barium, we have the next element. Let's highlight that one. There's Ba. I'm not talking about Ba, you know, like bad, you know what? Barium is Ba. It is pretty Ba. But there it is. The electron configuration, it is in group number, or period number 6. It should have 6 rings. So 2, 8, 18, 18, 8, 2. That is configuration. If they give you a simple question on the regions, what's the electron configuration for barium? Hopefully you could find it right there and say, oh, that was an easy one. 2, 8, 18, 18, 8, 2. Another thing you could do, you could add up all those values right there and say, oh, that should equal the same number as my proton number. So if I add them all together, it should equal 56, and it will. You're putting it in correctly. Electron configuration total equals the proton number. There's 6 rings. Good. Another thing to note, the maximum number of electrons in each ring, the first ring has a maximum of 2 electrons. You can never have more than 2 electrons in the first ring. The second ring has a maximum of 8 electrons. And the third ring has a maximum of 18. So it's 2, 8, 18. The next value would be 32, the maximum number of electrons you could have, which we'll see soon. 2, 8, 18, 32. The maximum number of electrons you could have, you should be aware of. 2, 8, 18. Then you could have 32, but it might not be 32. It might be less because orbitals. But lead, the last one I do want to check out for electron configuration. This one's an outlier. Let's find lead. Lead is Pb. If you're scrolling through the periodic table trying to find lead for a while, go to the next page. Look for lead, because this looks intimidating. I know it does. There's a lot of stuff going on there. But
It's number
again,
82.
Yeah, so it's number 82. So if you're analyzing, you're like, where the heck's lead? I don't know where it is. Break it up. It's not that bad when you break it up. So find lead. Someone said it's element number 82. You can find it right here. Element 82 is definitely going to be lead. So there's lead. Find element 82. The periodic table of elements is arranged by increasing atomic number, which you could see 3, 4, 5, 6, 7. Works like that, like you're reading a book. There's element 82. Let's zoom in on that now. Element 82. Boom. Chakalaka. There it is. All right, so you're looking at this and you could easily find the electron configuration. Say, oh, it's dash 1832, 184. I'll throw that down for now. We're throwing down 18-32-18-4. But then you start thinking and think about the concept we talked about earlier in class. It's PB we're analyzing. It's in period number 6. So when I zoom out of that, it says period number 6. It should have 6 rings there, but that doesn't have 6 rings. So you're like, what's going on here? That is definitely cray-cray. So you're saying period 6, it should have 6 rings, but it only has 4 rings. So this is another big thing you should definitely be aware of. It says right here on the bottom of the reference table. Boom. It says denotes the presence of 2-8 for elements 72 and above. So every element greater than 72 is missing the 2-8. That little asterisk tells you if it's greater than 72, you have to put those in the 2-8. So every element greater than 72 must have that 2-8 incorporated. It's on your periodic table as well at home. So there's my asterisk. It said every element greater than 72 must have the 2-8. So element 56 has 2-8-18. All right, that has 6 rings. But this element only has 4 rings. So you have to add 2-8 in front of all these elements, including PB. So PB, if you check it out again, has dash 18, 32, 18, 4. You have to put the 2-8 in front of that one as well. So every element greater than 72 has to have that 2-8 in front of it. Yes, Jumila. So the dash in front of the 18 is because you need a 2-8. Yeah, so basically if there's a dash in front, it means something's missing. What's going to be missing? The first shell and the second shell. Why don't they put it? It's because like they run out of space, and I guess there's just not space to really squeeze 2-8 in there with that size font. Maybe they want to make it a little bit more difficult for you to figure out, but 2-8 has to go in front of everything greater than element 72. And I fixed it here too. Questions on that? So that's electron configuration. All right, moving on forward. The shortcut allows you to cut the first 2 orbitals shortened by the address. So if it had that dash before, you know it's going to have the 2-8. If they ask for the regions for electron configuration for lead and you leave it out like that, that's wrong. You need to put the 2-8 there. So it has now 1, 2, 3, 4, 5, 6 rings. I know it's going to be in period 6. This has 6 rings, period 6. 4 rings, period 4. 4 rings, period 4. Should be aware of that one. All right, next up is going to be valence electrons. So these guys are responsible for bonding. Valence electrons are what are going to bond with each other. So valence electrons are electrons found in the outermost shell, the last shell. So outermost shell. Outermost shell. It is the last number in electron configuration. The last number in electron configuration. We'll practice these questions, how to figure out valence electrons. Again, these are responsible for bonding. The valence electrons are what are going to bond. The last shell of electrons are what are going to bond. These ones inside are called kernel electrons. So that's going to be kernel. You don't have to highlight it. You're going to I'll highlight it later. That yellow one's going to be my valence. So we have valence electrons. And then my kernel electrons would be the everything besides that. So it's going to be the inner electrons. Inner electrons. All the non-valence electrons. Let's check out a few examples. We have chlorine. The first one on up is Cl, chlorine Cl. The electron configuration for chlorine is going to be 2-8-7. So there's chlorine. I'm not going to zoom in anymore. That's Cl, it's chlorine. Hopefully by now you can figure out how I know Cl is going to be chlorine. Go to the next page, find Cl, and hopefully you can make that connection. Element 35. Nope, not 35. Where is it? Chlorine, chlorine, chlorine. 17, I'm sorry. Element 17 is going to be chlorine. So element 17 is going to be chlorine. We made that connection. So I'm zooming in on chlorine over here to the right. 35 bromine. My configuration is going to be 2-8-7. My electron configuration is 2-8-7. So that's my electron configuration, 2-8-7. The number of valence electrons is the last shell. There's my last number of electrons. It's going to be 7. And the kernel electrons are going to be everything besides the valence, which happens to be 2-8. If you add them together, it says number of kernel electrons. Number of kernel electrons got to be 10. 2 plus 8 equals 10. So if I add them both together, we should get 17 in both situations, no matter what. Easy. These guys are responsible for bonding. What's my electron configuration for nitrogen? Anybody? Electron configuration for nitrogen. Yeah, 2-5. There's nitrogen. 2-5. So configuration is 2-5. Valence electrons. This is going to lead into like tomorrow's lesson. Valence electrons are electrons in the last shell. There's going to be 5. And the kernel is going to be 2. 2 kernel electrons. Kernel electrons are not responsible for bonding. Valence electrons are. Next one, sodium. What's the electron configuration for sodium? Sodium, awesome. Sodium, awesome. So 281, there it is. There's sodium. Na is sodium. 281, thank you. Sodium 2-8-1. Kernel electrons got to be 2 + 8, are going to be 2-8. The valence electrons are going to be just 1. So 1 valence electron. 2 and 8 gives you 10. So again, the valence electrons are responsible for bonding. Kernel are not. Let's do a little example on this now. So we're getting into bonding eventually, but I'm going to slowly add more and more stuff to you. All right, so we have Cl. Cl has 7 valence electrons. So 7 valence electrons are going to be represented by dots. So dots are going to be represented like this. These are electrons. One goes to north, one goes to east, one to the south, one to the west. The maximum number of electrons you could have is 8 though. So I have 4, this would be 5, this would be 6, this would be 7. When something bonds, it will get to a stable octet, which means octet means 8. So you could have a maximum of 8 electrons when something bonds. So you can see there's room for something else to jump in there. Sodium, the stuff you put on your French fries, is sodium chloride. So if I take nice patriotic blue, well, kind of, and take sodium, sodium has 1 valence electron. Boom. What's going to happen when you make the table salt or sodium chloride is this one little valence electron that I have right there, 1 valence electron, boom, is going to say, I'm not really connected to you anymore, sodium. I found a new lover, and I'm going to jump in and bond with Cl. So this Na is going to be donated. You could release the Na, and it could jump in with chlorine to bond. So that Na is going to lose its electron, and Cl is going to take that electron. So now I'd have 2, 4, 6, 8 electrons around the Cl. So that's how the bonding of NaCl happens. It makes a stable octet here. What happens to the charge once Na gets rid of an electron? Let's make some connections now. If Na loses 1 electron, what's my charge going to be? Yes, Kai, thank you. If something lost an electron, if this guy loses an electron, the charge is now going to be +1. What's the charge of Cl if it gained that 1 electron?
-1.
Good. That's good stuff right there. So -1 would be the charge of that one if you lost an electron. So this would be a -1 for a charge. So that's what happens when Na and Cl bond. This guy loses an electron and jumps in right there. Let's make another connection. So I have Na plus and Cl minus. Let's go back to the reference table. Great. So let's find Cl. Let's go to Na first. So Na has a charge of, you can't really see it too well. Na has a charge of +1. So this guy has the ability to lose one electron. So that one electron that's in the valence shell right there, that one electron that's there could easily be released, could give off it pretty quickly. Change the configuration to 2-8. So that one electron that was initially there is released. It has a charge of +1. It can lose one electron very easily. Notice that this shell is going to be now 8 electrons in last shell. So that works out. Let's check out the Cl. If you don't understand this yet, it's not a big deal. We'll go through it and go to bonding a lot more. But I'm introducing it. Cl, what happens, we look at Cl and it has, right now, it has initially 7 valence electrons. What happened, it took another electron in from the Na to make it 8. So this one has 8 valence electrons around it. If I took one more in, it's going to have a charge of -1, which would mean it gains one more electron to give you 8. Maybe made those connections, maybe not, but we'll go through all that stuff later too. All right, so back to this drawing board. That's bonding. Let's do these questions. So I'll wait for the first 5 correct answers, then we'll move on from each of these questions. More for a review here. It says, give the correct electron configuration for oxygen atom, an atom of oxygen. Please tell me what the configuration for oxygen atom is. 1, 2. Thanks, Alex. Thanks, Nandel. Kai, good. 3. 2 more. Thanks, Philip. 4. 1 more. O's electron configuration is 2-6. Thank you, Joseph. Give the correct electron configuration for K plus ion. K plus ion. I'll wait for 5 correct answers. Yes, Alex, thank you. Yes, Leonardo. 2. K plus ion. Yes, Kai. K plus, there it is. Talking about that plus. We have 3 so far. So what the heck does that mean, that plus? Think about it. Plus means, are you adding an electron or taking one away? Yes, a C. All right, Joseph, yes, but you don't put that last 0 there. You wouldn't lose credit, but it just doesn't need to be there. All right, so yeah, it's gonna be 2, 8, 8. Every element in group 1 has the ability to lose 1 electron. So that could lose 1, that could lose 1. Rubidium, it could lose that 1 electron. Cesium could lose 1 electron too. So 2, 8, 8, correct. How many valence electrons are there in fluorine? Fluorine is F. How many valence electrons? Yes, Kai. Alex, just that last number. That's valence electrons. That's electron configuration. Alan, yes. I have 3 answers. So find F. How many valence electrons are in the last shell? Yes, Joey. Asim, thank you. 7. So it's going to be 7 valence electrons in F. Thanks, Joey. Checking that out. 7 valence electrons for F. How many electrons in the last shell? Boom, right there. Just cross it out. I realize like my clicking of the mouse is really annoying from when you video or hear this, so I apologize. So there's 7 valence electrons. Last shell. How many electrons? Valence electrons are in F minus ion. Yes, Kai. Yes, Joseph. Yes, Leonardo. Oof, Asim, just that last number. Valence electrons are electrons in the last shell. 8. If it gains 1 more electron, that minus means you're gaining 1 more electron. There's going to be 8 there. How many kernel electrons are in P, phosphorus? Kernel electrons in P. Yes, Alex. Kernel electrons in phosphorus. Yes, Joe. Yes, Kai. See, thank you. 10. 2 plus 8 gives you 10. How many valence electrons are there in phosphorus? That's Kai, Alex. So as I pose these questions, hopefully you could do them too. See a lot of the same answers, same people in here. Hopefully you're seeing this. Hopefully I'm not going too fast either. So valence electrons are the last shell. There are 5, which that number is. So 5 valence electrons. And last one, how many principal energy levels are there in bromine atom? So bromine atom, how many rings are there in Br? My element, which is a liquid. So find Br. There it is. That's Alex, that's Kai. Leonardo, thank you. How many rings? 1, 2, 3, 4. It's in period 4 as well. So there's 4 rings, which leads us to a boring model. So 4 rings. 4. All right, so that's the basics of valence electrons and electron configurations. Next up is going to be boring topics, Bohr rings. We're going to make a couple models. You know how to do this already. But the Bohr rings, one method for expressing electrons located in the atom or ion. And the electrons must be drawn. All electrons must be drawn. All electrons must be drawn with a Bohr ring. You could read through this, but you already know how to do Bohr rings. See what time we're at. So hopefully we'll get through at least, oh, we actually made this one already. We'll get through one more example for making the Bohr rings. So hopefully you already made the carbon atom. I'm going to scroll on up and find my atom for carbon. I'm going to copy it. Life's good. Life's good, Joe. Thank you. How about for you? Nice. Having fun. Okay. Find the simple joys in life. Go out there. Go for a run. Work out. Maybe do 20 push-ups a day. A couple 100 crunches a day. Make yourself feel a little bit better. You could easily get depressed in this time we're in. So find the simple joys in life. If I were you, I'd be trying to go outside as much as possible and take advantage of that stuff. But winter is going to be a long winter. We're going to be like stuck in your house and wanting to escape. Maybe like snowshoeing. Never did it, but maybe it sounds fun to you. Maybe you'll help out with like when the snow falls and like shovel the driveway all the time just to get out, get a little mental state in there. Why am I going off on a tangent? Because Joseph asked how life is, and I don't know. I figured I'd just talk to you a little bit. I'm locked up in my basement. My kids are going crazy upstairs. Not that crazy. All right. So, anyways, what happened here? I just scrolled on up during that whole heart-to-heart session. I am back on subatomic particles, and we made an atom for carbon. What I'm trying to do, I'm going to take this little. Jumila, do you need more time for that? I'm sorry. I go back to that too. So click on this little atom that you already made for carbon. I'm not going to make it again because it's already here. So mine happens to be on right after subatomic particles. So double click on that. This is a boring. Brings you to the drawing board. And I'm going to take this image that I already created. So I have to zoom out a little bit. Control negative makes you zoom out a little bit. So what happened, how did I get that little image there is just, I left clicked it, dragged it on down. If you're using a Mac, it might be a different feature. So left click it, drag it on down, and then release. You should have this atom. I'm gonna hit Control C to copy. Just copy that in. Once you have it copied, I'm going to save it, close it. And then I'm not going to make this one again. I'm just going to paste it right under carbon. So scroll on down. double click on carbon, or just go inside that cell. It's called the little text box there. Make sure you click inside there, and then hit Control V. And that looks horrible. And it didn't work out for me. Hopefully it worked out for you. I try to save myself time, but I don't know if it's gonna work.
No, it didn't work for me either.
All right.
Yeah, me too. It didn't work.
I'm sorry, guys. Wasted your time there. All right, so let's just make it quick and then we'll get out of here for the day. I think we have enough time to. So electron configuration, I'm just going to go really quick through this one. Electron configuration for carbon, you can find the reference table is 2-4. So 2-4, you're inside that little box. So 2-4. What we're going to do, first off, we're going to be inside that one little box, and I'm going to make an image in here. So I'm going to insert image, or insert drawing. Make sure you click on this. Make sure you're in that box before you go to this next feature. Insert drawing, new. I'm going to take a nucleus, a circle, insert shape, circle. I'm gonna make a, if you hit shift and then drag it, it's gonna make a nice perfect circle. This is my nucleus. My protons, P, control, period, positive. Protons equals, should be lowercase p, p, protons equals 6. Doesn't have to look exactly like mine, it's fine. And then the neutrons are equal to, so take your time making the first one right, because then the rest of them, you're just going to copy and paste. You will have the ability to copy and paste there. So I'll make my font a little bit smaller, just so it all fits in there. Neutrons equals 6. Should be lowercase n, and it should be lowercase p. I have my cap locks on. So you can represent the positives, negatives, you don't have to. Where's this atom supposed to be? This atom's going to go right into this carbon box, so we're going to eventually put it in there. So make sure it's clicked on there. Going back to my features, now to put my electron configuration of 2-4. Take your ring, make a ring. So I'm going to go through this relatively quickly, and then I'll go through it again if you need more help. So there's my first ring. I'm going to make it transparent. Go to the paint can, take the paint color away. Center it up with these arrows, they're nice. There's the first ring, and I need a second ring there too, because there's 2 rings. It's in period 2. So second ring has to be bigger. Again, make it transparent. And the last thing you need to do is make your electrons. My electrons are my smiley faces. I'm going with electrons being smiley faces from now to the rest of the year. So make a small little electron, and I just paint mine yellow. And I need 6 total. There's 1. I'm hitting Control C and pasting this in 5 times. 1, 2, 3, 4, 5. Configuration's 2-4. I have 2 electrons on the first shell. So we actually did this already, so you should be aware of how to do most of this stuff. 2 electrons on the first shell, and then there's 4 on the second shell. Once you're done with this, please save it and close it, and that's it for today's class. You cannot do topic number 5 homework yet. There's still more information you need to complete. So if you're done, save it and close it. Make sure it pops into that one cell, because next time we're just going to copy this and paste it and maybe add more electrons or manipulate it a little bit. So it won't take as long for the next 4 examples. If you're done, save it and close it. You can adjust its size. I like to wrap it so you can move it a little bit more. That's pretty cool. You can make that little atom in your computer now. It's cute. Does anybody have questions? Feel free to ask questions. I know today's class went fast. It always goes fast, I know. I feel that way all the time. I could stay here for hours talking about this stuff. If you have questions, I'm here. That's it for today's class. Have a great day. Make good decisions. I'm glad it flew by, I guess. Go for a walk outside. Take care.
Great day, Mr. Brown.
You too. See you later. Make good decisions.
Bye. Have a good day.
You too. Thank you.
Bye.
Bye-bye.
Have a good day.
Thank you. You too, guys. If you need help, please ask for help. Bye, Seem. Have a good one. Bye, Nadal. Have a good one. See you, Kim. See you, Irvin. Have a good day. See you later, Joey. Joseph, have a good day. Bye, Nadine. Have a good one.